So if it is asked to design adder-cum-subtractor,
Yeah.
so 4-bit, 4-bit
Yeah.
adder-cum-subtractor. So we have to know then, this is what I was telling, like, writing in C, C++ or Verilog is secondary thing.
Yeah.
Primary thing is the given task, how we understand that is the primary thing.
Yeah.
So do you have any idea actually how you can get this done?
Subtractor, I don't know. Adder, what I have
No, no,
understood, like,
adder-cum-subtractor. That should include both.
uh,
Have you ever come across on it?
I think I've come across. I think with some instruction you can select whether it's performing as adder or subtractor. That's one thing, and then adder circuit we have already done, and for subtractor, I think some different circuit was it. I think using two's complement or something you do subtractor.
Okay. Okay. So that is how it is. So let's say, mm, as you said, a two's complement.
Yeah.
So if we have to do this A plus B, we have some like whatever something. So there's no problem, like we can go with this addition 1 plus 1, that is some 0 carry out here. And this
Yeah.
plus 1 is some 0 carry out is 1. And some 0 is added with this 1. So that will give us 1. 1 plus 0 is 1. That 1 plus 1 will give us the carry out 1, some 0. And here this 1 plus 1 carry out and some 0 plus this 0 is 0. And finally this carry.
Yeah.
So that's how that plus addition that is. But the moment
Yeah.
we ask to do this subtraction for the same, then what is required is, as you said, we require to convert this one to the two's complement.
Yeah.
To convert this to the two's complement, what we require to do is first get the ones complement of this
Yeah.
and then add to that ones complement plus 1.
Yeah.
So that is what we have to do. So to do that one, in the hardware point of view, we have something, this gate. If you take this gate, y- and the truth table of this is like this is A, this is B, and this is your Y. So you have A, B, and this is 0, 0, 0, 1, 1, 0, 1, 1, and your Y here. That is for 0, 0, it is 0. For 0, 1, it is 1. For 1, 0, it is uh, 1. For 1, 1, it is 0.
Yeah.
So now, if you look at this one and this one, in both cases, it is 0 and it is 0. Only,
Yeah.
only in this case, only in this case, it is like you are complementing. Like if it is 0,
Yeah.
sorry, 0, 1, then this is 1, this is 1, 0, this is 1. So
Yeah.
in this case, somehow we have to do something of that sort. What is
Yeah.
we do is, let's say we are tying this to one, this one input, we are tying to 1. And this another input, if you are giving the same 1, then we get this is 0, because this case it is, this is 1 and this is also 1. So we got the output 0 here. When this is 0, then you
Hello.
complete
Yeah.
complement of that one.
Yeah.
So now what is actually happening here is one's complement you are doing. Once to do this one's complement,
Yeah.
all the bits that you give here,
Yeah.
the bits that you give here, they are complemented.
Right.
So here complement is happening for 0, we are getting 1. For 1,
Yeah.
we get 0.
Yeah.
This 1, if you give, this is 0. If you give the
Right.
0, you are getting 1.
Yeah.
This is complement, you are complementing.
Yeah.
This complement happening only when you tie one input of the XOR gate to 1.
Yes. Yeah.
So it means what? You, you obtain the ones complement.
Yeah. Yeah.
So, and there is a requirement of adding this one.
Yeah.
So now if I take here one full adder here and another full adder here, one
Yeah.
full adder here, one more full adder here, 4-bit, na?
Nice. Yes. Full. Yeah.
So now what I do is I give as it is this A3
Yeah.
and A2, A1,
Yeah.
A0.
Right.
Now, so now, if I put here this gate, and if I give here, and one input, if I'm giving here B0,
Yeah.
and this one is my control,
Yes.
and here I give this XOR gate again, and one input here is B1, and this one will be going to this control.
Yes.
And this again XOR gate here. And here I will be using B2, and this another input will go to this control.
Yeah. Yeah.
And here one XOR gate, and one input will be B3, and another
Yeah.
input is going to this control.
Yes.
Now control also given here to the first full adder here.
Right. Yeah.
And this full adder going to give us result 0, and carry out if generated, that is going to the next full adder, and this is going to give us result 1. Carry will be going to the
Yes.
next stage, and it will be giving us result 2. Carry will be going to the next stage, and this is going to give us R3, result 3, and this is
Okay.
your final carry out.
All right. Yeah.
Now, what happens when control is 0? Control is 0 means
Yeah.
this bit here. This bit is 0 means if this bit is 0 means if you are giving here 0, you get 0. If you are giving 1, you get 1.
Yeah.
That is what, na? Whatever the bit
Yes.
you are giving, you are getting here.
Right.
When this is 0, control is 0.
Yeah.
Control 0 indicates here add operation.
Right. Yeah.
Then you are adding A0 to B0, A1 to B1 as it is, you are not complementing A2 to B2, A3 to B3. Na?
Yeah.
So, but the moment control is 1,
Yeah.
control bit is equal to 1, it means you are actually performing subtraction.
Right. Yeah.
Subtraction means you got to know that this since this bit is this input is 1. So B0,
Yeah.
whatever you give, that complement you will get here.
Right.
And here also complement you will get here also.
Yeah.
Here also complement. Here also
Yeah. Yeah. True.
complement. So what you are
Right.
doing is basically all the complemented bits like of the B0, you already have A0, A1, A2, A3, and the
Yeah.
complemented of the version B plus one also you are doing this one. This one is
Yeah.
also applied here, na?
Right. Yeah.
So that way, actually, this entire thing is actually two's complement, na?
Right. Yeah. 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 True. Got it.
So that way you are performing both things with this
Yeah.
kind of circuit.
Yeah. Okay. Got it. Got it.
When your
Yeah.
control is zero, you are performing the addition operation. When your control is one, you are performing the subtraction.
Yes.
So now this circuit requires to be developed. So what we develop here is we develop the full adder code. We use this XOR gate.
Yeah. Can you pause for 1 second?
So let's say if it is set to here you you have only decoder.
Yes.
Uh, you are asked to build the full adder using that one.
Yeah. Decoder, probably little bit of theory I might need.
So this is another problem. Like, you do not have now access to your this gates like XOR gate.
Yeah. Yeah.
You only have the decoder with you,
Yeah.
and some other gates may be there. But like for example, OR gate.
Yeah.
With the help of these two, how you come up with this full adder?
Okay.
That could be one problem that you can think.
Okay.
And this is one thing that is and other is you can think like this also, like a D flip-flop. Instead of doing the way we do the for flip-flop, like we do it with the gates, feedback gates.
Yeah.
Uh, like this, the output of this is fed to this gate, and this gate is fed back here. So
Yeah.
internally, that's how we build actually.
Yeah.
So instead of that, if it is asked like you have mux available with you,
Yeah.
now build this D flip-flop.
Okay.
So that is another problem that you can think of. Like uh,
Okay.
I do not have any gates with me available, so that by making use of these gates, I can build a D flip-flop.
Yeah.
But I have only mux available. But using this mux, we had to build this D flip-flop. How do I build a D flip-flop? Is another problem.
Okay.
Now, yeah, you think and will continue. For this, you write the Verilog code test bench.
Yeah.
And
Right.
you think about this, how you can develop.
Okay.
No problem. If you Google also, no problem. You can
Yeah.
Google that one. But thing is, you have to
Yeah.
understand the concept and be able to write the Verilog code, be able to write the test bench.
Yeah. Yeah.
The
Right.
primary goal is to convert the understanding into the code.
Right. Yeah.
And this also,
Yes.
how do you build the D flip-flop using the mux?
Okay.
And be able to develop the code for that and be able to simulate that one, like using mux, if you could able to develop the D flip-flop, how are you getting the results or not?
Okay. All right. Got it.
So with that, we today we will stop.
Okay. Yeah. Fine.
And
Yeah.
as you said,